The Kuiper Belt is a region left over from the early history of the solar system. Its general shape resembles a flattened disk or donut, with the main region terminating approximately 50 astronomical units or AU from the Sun. This region surrounds the outer edge of the main part of the Kuiper Belt, which in turn is surrounded by a second region called the scattered disk, which extends even farther out. Astronomers believe that the icy objects in the Kuiper Belt are remnants of the formation of the solar system, similar to how asteroids in the main belt are remnants of the formation of Mars. This is an area where objects could have coalesced to form a planet if Neptune had not interrupted the process. More than 2,000 known Kuiper Belt objects called KBOs have been catalogued by observers, although they represent only a small fraction of the objects believed to exist in total. The Kuiper Belt is a true space frontier that we are still exploring, and our understanding of it is far from complete. There are many mysteries that we have yet to unravel. The hypothesis about the existence of this belt was first proposed by astrophysicist Frederick C. Leonard in 1930 and Kenneth E. Epworth in 1943, which led to it to also being known as the Kuiper Belt-Epworth Belt. Dutch astronomer Gerald Kuiper proposed the existence of this region in the 1940s, which led to the belt's current name. The Kuiper Belt is a region where objects are relatively small, mostly tens to hundreds of kilometers in size, with the largest bodies comparable to Pluto. They are composed mainly of ice and rock, which has earned them the name icy dwarf planets. Their orbits are highly elongated and are inclined with respect to the planet of the ecliptic due to their unstable orbit, which means that many of them can cross Neptune's orbit or even enter the solar system. The Kuiper Belt is home to Pluto and Eris, both of which were visited by the New Horizons spacecraft. There may be millions of other icy worlds in the Kuiper Belt, which are remnants of the formation of our solar system some 4.6 billion years ago. These objects, known as KBOs or trans-Neptunian objects, lie far from the Sun and may help answer questions about our origins in space that were previously unknown. This area is believed to be the source of short-period comets, such as Halley's Comet, although it is estimated that there are about 70,000 objects in the Edgeworth-Kuiper Belt Comet Belt, or SER, with diameters greater than 100 kilometers. The total mass of the belt is relatively small, perhaps comparable to or slightly larger than that of the Earth. Many objects near Kuiper Belt have orbits that are far from the plane of the ecliptic. Computer simulations suggest that the Kuiper Belt was formed by the gravitational influence of Neptune, which holds back small objects that cannot completely escape the solar system, as well as other objects that formed in situ. Simulations and other theories predict that there may be Mars or Earth-sized objects within the belt. The outer limit of the Kuiper Belt is not clearly defined, but there appears to be a decrease in the density of objects beyond the observed limit. This phenomenon is sometimes referred to as the Kuiper Cleft or Kuiper Wall, although the reason behind these names is enigmatic. Pluto, the small dwarf planet in the solar system, is considered to be part of the Kuiper Belt, along with other objects. It has an eccentric orbit inclined with respect to the plane of the ecliptic. Objects in the Kuiper Belt with orbits similar to Pluto's are called Lutinos, while other objects are grouped into various classes. The remaining objects with more classical orbits are classified as KBOs or trans-Neptunian objects. The Kuiper Belt presents a marked void at a distance of 49 AU from the Sun, where the number of observed objects increases markedly, creating the Kuiper Wall. The cause of this void is still unknown, although it is speculated that something of considerable size could exist beyond the belt, possibly the size of Earth or Mars. However, this prospect is a matter of debate. Most models of solar system formation indicate that the first icy dwarf planets formed in the belt and subsequently, due to interactions, some of them dispersed outward and fell into the region known as the dispersed disk. Any object orbiting the Sun in an orbit within the defined range of the belt is considered a Kuiper Belt object, regardless of its origin or composition. In some scientific circles, the term rogue planet is used as a synonym to refer especially to objects that are believed to originate from the outer edges of the solar system, even though they have orbited the Sun beyond this belt for billions of years due to the unique dynamics of this region. Some scientists propose the existence of a ninth planet in the Kuiper Belt, beyond the orbit of Pluto. During the 229th meeting of the American Astronomical Society, James Vesper, a graduate student at New Mexico State University, along with his advisor Paul Mason, used computer simulations to explore 156 scenarios of solar system interaction with planets at various scales in orbit. Such encounters are not uncommon, with some studies suggesting that the number of rogue planets is significantly greater than the number of regular planets in the entire Milky Way galaxy. Simulations indicate that 60% of these encounters, the rogue planet will be ejected from the solar system, while 10% of the cases, it will capture at least one planet in our solar system before being ejected. In 40% of the encounters, the rogue planet will be captured and become part of the solar system, which may result in the ejection or displacement of an existing planet. The alleged ninth planet is believed to be at least 10 times larger than Earth, which could cause significant disturbances within the solar system. Its existence was firstly seriously considered in October 2014 by astronomer Scott Shepard at the Carnegie Institution for Science in Washington, D.C., and Chadwick Trillo at Gemini Observatory in Hawaii. Shepard and Trillo pointed to the gravitational influences of an unknown giant lurking beyond the solar system, which could explain the peculiar orbits of some objects located extremely far away, such as the dwarf planet Sedna. In 2016, astronomer Mike Brown of the California Institute of Technology discovered a new object called Orchis within the Kuiper Belt, which is more massive than Pluto but also has a very unstable orbit which could extend beyond the orbit of Neptune. Brown referred to this hypothetical ninth planet and calculated that it could have an elliptical orbit with a distance from the Sun of about 1,000 astronomical units. Vesper noted that the supposed orbit of the ninth planet aligns with the scenario of a captured rogue planet. However, it was also emphasized that the results of the simulations did not provide definitive evidence for the actual origins of this hypothetical planet. In reality, astronomers have not yet confirmed the existence of a ninth planet in our solar system. Some alternative investigations suggest that this planet could be an original member of our solar system, or perhaps it was captured by the Sun during a previous encounter with another star system. The search for a complete understanding of the ninth planet is ongoing, and astronomers continue to investigate various possibilities to explain the observed features in the outer solar system. Astronomers have been researching for many decades for objects from outside our solar system. However, it is in the moments of greatest desperation that the most surprising things happen. After years and years without news, something completely unexpected finally happened. Two objects made their appearance at the same time, attracting the attention of scientists and astronomers from all over the world who used the James Webb Telescope to dive into the investigations of these mysterious visitors. What are these two objects that appeared at the same time about? If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, hit the like button, and activate the notification bell. The first object to emerge from the vacuum of space was barely discernible through an observatory's telescope. After focusing the James Webb Space Telescope on this object, it was discovered that it had emerged in Vega, a distant star, and traveled through space at an impressive 50,000 miles per hour, and was 147 trillion miles away. Its shape was similar to that of a cigar, and it was 1,000 meters long. Although this dimension was not particularly large for a comet or asteroid, since it was believed that it might be one, it was necessary to assume that it was an asteroid or comet. It was speculated that this object might form in a spacecraft-like disk, and when it was finally detected, it had already passed close to our star, the Sun. It made an abrupt trajectory change and began accelerating in a different direction, a behavior that was certainly a departure from what would be considered normal for an asteroid or comet. And just when astronomers were thinking about assimilating the surprise and confusion caused by this unexpected visitor, another event took place. Gennady Borisov had the opportunity to observe an object moving across the sky before dawn. The sighting occurred from his own personal observatory in Orkney, Crimea, using a telescope he had built himself. From the first moment, Gennady recognized the peculiarity of what he was seeing, as his object was moving in a direction opposite to that of the comets that is normally inhabit the main asteroid belt surrounding the Sun. The question that remains is whether these interstellar visitors are of natural origin or whether they are the product of some form of artificial creation. To obtain answers, it would be necessary to undertake a journey to them and conduct closer investigations. The first interstellar traveler came from the Vega star system and was given the name Hawaii, which in their language means explorer. Vega, also known as a future North Star, is a bright star only 25 light years away from Earth. It is visible in the northern hemisphere sky during the summer months due to the slow roll of the Earth's axis, which gradually shift our perception of north to various stars. A millennia ago, Vega was a pole star, and in about 12,000 years, it will regain that position. In early 2013, astronomers made the discovery of an asteroid belt surrounding Vega, suggesting the presence of possible planets in the star system. Among the objects present, two regions were identified, an outer one populated by asteroids and an inner one with hotter space rocks. One of these objects was named Oumuamua. NASA had a window of only 11 days to observe Oumuamua, as it traveled at 3 times the speed of the Earth's orbit around the Sun. After that, the object was no longer detectable due to its small size and low luminosity. After entering our solar system and passing the Earth, it accelerated sharply to leave our system. During the follow-up of Oumuamua, it was anticipated that its orbit would have a hyperbolic shape, being influenced only by the gravitational force. However, something unusual was demonstrated, an additional acceleration that seemed to push it in addition to gravity, which defied expectations. When the cigar-shaped object was sighted, it had already passed close to the Sun and changed direction, turning abruptly. Scientists were troubled by 2 questions in particular. First, its enigmatic acceleration away from the Sun, and second, its peculiar shape. Despite NASA's effort, speculation abounded in scientific journals and media headlines. Although it was initially labeled as an asteroid and later as a comet, uncertainty persisted about its nature. In the midst of this uncertainty, Avi Loeb, a Harvard astronomer, raised the bold possibility that it could be an artificial structure created by an intelligent entity. This suggestion resonated because the object changed the understanding of conventional physics, baffling the scientific community. After its close approach to the Sun, the object began to leave their solar system at an exceptionally high speed, approximately 95,000 kilometers per second, much faster than would be expected for a traditional comet. Instead of showing chaotic acceleration due to outgassing, its acceleration was smooth and steady. a behavior uncharacteristic of a comet. On October 7, 2017, Oumuamua headed towards the constellation Pegasus, headed for an unknown destination. Although an image could not be captured due to limited technology at the time, its peculiar characteristics suggest a possible artificial origin, such as, for example, a craft with a light sail. Initially classified as a comet, then as an asteroid, as it did not show a fuzzy coma, the discovery of Oumuamua was an oddity, as it did not fit the typical patterns of objects in our solar system. Despite observational efforts with telescopes at Green Bank, West Virginia, and Allen, California, no signals or communications from the object were detected. In contrast, the other detected object, 2I Borisov, was easier to understand than its cosmic companion. This interesting comet, composed of a mixture of water, dust, and carbon monoxide similar to that found at the periphery of the solar system, had a visible tail and was more in line with specific expectations. However, 2I Borisov seemed even more mysterious in comparison. It is argued that its origin comes from an ancient solar system that was in orbit around a red dwarf. This is a type of stars of low luminosity and common in our galaxy. Based on its velocity and trajectory, an international team of researchers has theorized that it possibly arose near the white dwarf Ross 573, located in a region of space about 629 trillion kilometers away from the Sun. Their hypothesis suggests that it was ejected into space about 900,000 years ago as a result of a violent collision between three large objects in this celestial area. Although some have even put forward the idea that it could be an extraterrestrial civilization observing us, it is more plausible that it is a natural object. Nevertheless, there is the possibility that an advanced alien civilization has built a spacecraft capable of going unnoticed by the naked eye. In the vast space of our solar system, there is an asteroid called Apophis that poses a potential threat to Earth if it were to collide with it, which could have catastrophic consequences. On April 13, 2029, this huge asteroid will pass at an incredibly close distance, just 19,000 miles from Earth's surface, even closer than some satellites. However, uncertainty about whether Apophis will impact Earth in 2068 raises concerns about the possibility of unprecedented devastation and whether we are prepared to deal with such an eventuality. We will explore this issue further. The discovery of Apophis in 2004 was an alarming event, at a time when our understanding of near-Earth objects was still developing and our tools for studying the universe were just beginning to scratch the surface of its mysteries. Astronomers using the Kitt Peak National Observatory in Arizona were the first to detect this asteroid, initially designated 2004 MN4, but later renamed Apophis in reference to the ancient Egyptian god of chaos and destruction, a name that reflected the concern it would soon generate. Apophis stood out among other asteroids for its considerable size, estimated at approximately 1,200 feet in diameter, making it a significant object among near-Earth asteroids. However, it was not its size that attracted attention, but also its orbit and characteristics, which made it an object of fascination and debate among the scientific community. Astronomers use advanced telescopes equipped with state-of-the-art sensors to detect objects like Apophis, tracking its motion relative to distant stars and calculating its orbits to predict its future trajectory. From the beginning, prominent figures in the field of astronomy, such as Neil deGrasse Tyson, have recognized the potential implications of an asteroid like Apophis, noting the importance of addressing this type of threat seriously. While many scientists were impressed and immersed in the technical details of the asteroid, Tyson used this platform to discuss the broader implications of these celestial bodies. One of his most remembered comments about his asteroid is, "The universe is a deadly place. At every opportunity, it tries to kill us. So does the Earth. But we humans are pretty good at avoiding death. As we explore the mysteries of Apophis, we will discover that the universe has its own surprises. Stay tuned." 2029, a ticking time bomb. In a startling revelation, the solar system seems to have a peculiar sense of time. On Friday, April 13, 2029, a major event will occur. Apophis, a huge asteroid approximately 300 meters in diameter, will approach Earth, passing just 19,000 miles from our planet's surface. To put that in perspective, it will be closer than some of our Earth-orbiting satellites. Before panicking, it is essential to note that scientists are confident that Apophis will not collide with Earth during this encounter. Instead, this event represents a unique opportunity for researchers to study near-Earth asteroids. However, as we will explore below, there is an even more disturbing twist to this cosmic story, involving the return of Apophis in 2068. Did you know that an object of this size only comes close to Earth once every 1,000 years? Well, this makes the 2029 event a unique spectacle. Richard Brenzel, a planetary scientist at MIT, highlighted the importance of this event during the International Planetary Defense Academy. He stressed that the size of a proximity of the asteroid would make it so bright that approximately 2 billion people would be able to witness its passage with the naked eye. Imagine looking up at the sky and seeing an asteroid, a relic of the early solar system, passing so close. One of the most intriguing aspects that scientists study is the Yarkovsky effect. This phenomenon is due to the difference in temperature between the daytime and the nighttime phases of the asteroid. The heat emitted by the surface can exert a small force, pushing the asteroid in a particular direction. Although this effect is minuscule, over time it can significantly alter the asteroid's orbit. For Apophis, understanding this effect is crucial. Although the trajectory in 2029 is well defined, the uncertainties associated with this effect make it difficult to predict the asteroid's trajectory in the distant future. Now, with a decade to prepare for Apophis' approach, scientists are gearing up for its arrival. They are ready to collect as much data as possible, not only to improve our understanding of Apophis, but also to better understand other potentially hazardous asteroids. After all, Apophis is believed to be similar to 80% of all the potentially hazardous asteroids identified so far. But there's an idea to ponder. What if we could study Apophis up close? Researchers are currently studying the possibility of sending spacecrafts to observe the asteroid before, during, and after its close encounter in 2029. What if the 2029 approach doesn't mark Earth's only encounter with Apophis? The year 2068 is on the minds of many astronomers and space enthusiasts. But why? Because it is the year in which there are a chance that Apophis will collide with our planet. This is where the concept of keyhole comes in. You can imagine it like throwing a stone into a pond. If you throw it with a specific angle and velocity, it might bounce back once or several times before sinking. Similarly, a gravitational keyhole is a region of space through which a celestial object, such as an asteroid, passes, where the Earth's gravity could alter its trajectory. In the case of Apophis, if it passes through a specific keyhole during its passage in 2029, it could be put on a collision course in 2068. Now, let's consider the implications of such an impact. What would happen if an asteroid the size of Apophis were to collide with Earth? Upon impact, the area near the point of collision would experience catastrophic devastation. Traveling at speeds of several kilometers per second, the asteroid would release energy equivalent to billions of atomic bombs. This would result in the formation of a huge crater, potentially several kilometers in diameter. The heat generated would be so intense that it would instantly vaporize both the asteroid and a significant portion of the Earth's crust at the impact site. This would result in the ejection of molten rock and debris into the atmosphere, forming a gigantic fireball that would consume everything in its path. If Apophis were to impact ocean or a sea, the consequences would be even more devastating. The collision would trigger huge tsunamis with waves that could reach heights of hundreds of meters. These waves would propagate throughout ocean basins, wreaking havoc on coastal cities and towns. In addition, the force of the impact would trigger seismic activity, which could generate earthquakes thousands of kilometers away from the impact site, affecting regions that are not accustomed to such events. The repercussions of the impact would have a long-term global effect, as a large amount of debris thrown into the atmosphere would block sunlight, causing a phenomenon known as impact winter. This phenomenon could last for months or even years, causing a drastic drop in temperatures around the world. Now, if you liked the video, remember to hit the like button, share it so it reaches more people, and subscribe so you don't miss out on more content like this. Thank you very much for watching, and I'll see you in the next one.